Circular motion. Consider an object moving counterclockwise in a circle, and whenever an object is moving in a circle, it experiences a force toward the center. This force is the resultant force, and you can take this object. The linear speed of the object is v, and it is tangent to the circle. Now, since it is moving in a circle, so there must be some force which is forcing it to move in a circle. That force is called centripetal force. Centripetal force is always the resultant force, and centripetal acceleration is also toward the center. Suppose the object is moving with constant speed, but since the direction is changing, you can see the direction tangent to the path is this at position A, and at position B it is like this. So two directions are different. So since direction is changing, so velocity, which is the speed plus direction, is also changing. So since velocity is changing, so the object is accelerating. So v is the linear velocity, and a small c is centripetal acceleration, and f small c is centripetal force. Take an example. The figure shows a model car moving clockwise around a horizontal circular track. And since the model car is moving in a circle, so it is definitely experiencing a centripetal force toward the center. And there is no string. Now you can imagine that what force is there to provide the centripetal force. Then friction between the track and tires is providing the required centripetal force. Now, if we look at the question, a force acts on the car to keep it moving in a circle. They say draw an arrow on figure 1.1 to show the direction of this force. So this is the arrow. The speed of the car increases. State what happens to the magnitude of this force. So since speed increases, so the force of friction will also increase. Otherwise, the car will go off track. So magnitude of this force will also increase. Now the car travels too quickly and leaves the track at P on figure 1.1. Draw an arrow to show the direction of travel after it has left the track. Now this direction is tangent to the track, tangent to the circle, and this is the direction of linear velocity. So the car move in this direction. In terms of the forces acting on the car, suggest why it left the track at P. The reason is quite obvious. The force of friction is not sufficient enough to hold the tires with the track. So that's what we write. Friction between the tires and the track is providing centripetal force. As I told you, force of friction is not sufficient to provide required centripetal force.